Let's take a look at this problem. We've got f of x is equal to 7x minus 1 over x squared minus 9. And we want to sketch a graph using all our different components. Our first one, the x-intercept. Now to find the x-intercept, you always plug 0 into the other variable, so I'll plug 0 in for y. So we got 0 is equal to 7x minus 1 over x squared minus 9. Whenever you're finding the intercept and you got a single fraction equal to 0, you can just set top equal to 0. So we've got 0 is equal to 7x minus 1. Take negative 1 over. You get 1 is equal to 7x, and divide both sides by 7. And we got x is equal to 1/7. Now for our y-intercept. You always plug 0 into the other variable, so plug 0 in for x. So we got y is equal to 7 times 0 minus 1 over 0 squared minus 9. Those zeros drop away, and we end up with negative 1 over negative 9, which is a positive 1/9. Our third thing is the vertical asymptote. Now for your vertical asymptote, our first step is to factor the top, factor the bottom. Can't do anything with the top, but the bottom is the difference of two squares, so it factors as x plus 3 times x minus 3. We would cancel, but there's nothing to cancel. So then we set our denominator equal to 0. So I'll set x plus 3, x minus 3 equal to 0. Now zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x plus 3 equal to 0 and x minus 3 equal to 0. And that gives us negative 3 and positive 3. Now our fourth item is the horizontal asymptote. Well, the degree is the largest power of x. The degree of the top is 1, the degree of the bottom is 2. When your degree of the bottom is larger, your horizontal asymptote is y is equal to 0. Excuse me, I knew that was coming. Okay, increasing, decreasing, min and max. We need to find our derivative. It's going to be quotient rule. This top part will be p and the bottom part will be q. We need p prime. Derivative of 7x minus 1 is 7. We need q prime. The derivative of x squared minus 9 is 2x. Our formula is p prime q minus p q prime over q squared. So for our derivative, p prime was 7 times q, which is x squared minus 9, minus p, which is 7x minus 1, times q prime, which was 2x, over q squared, which would be x squared minus 9 squared. Well, 7 times x squared gives us 7x squared. 7 times negative 9 is negative 63. And put the 2x out in front, so we got minus 2x times 7x minus 1 over x squared minus 9 squared. That gives us 7x squared minus 63. Negative 2x times 7x is negative 14x squared. Negative 2x times negative 1 gives us a positive 2x over x squared minus 9 squared. Let me continue over here. There we go. Combine to get some like terms. 7x squared minus 14x squared is negative 7x squared plus 2x minus 63 over x squared minus 9 squared. Now the top part, I doubt very much that would factor. 7 times 63, 441. But I doubt that give you any sense give you 2 here, but we'll just use a calculator, make our life easier. So go to y equals clear. We got negative 7x squared plus 2x minus 63. Have to have 0 on y2, and then I do second trace, choose intersect. And don't see it. So let me do a zoom, and I'll choose zoom out, so I'll do 3. And then I'll press enter one time once it comes back. Still don't see it. Negative 7x squared. Let me do zoom out one more time, press enter. I'm seeing a little bit right there. You see that down here? Let me do a zoom and choose Z box. And I'll move my cursor down. And maybe about right here. Press enter one time. And I'll do my right arrow. Just want to confirm it's really down here. Get down to about right, I don't know, let's say there. And then I'll press enter. It is down there. Which means it never goes up far enough to cross the x-axis. Well, let's do zoom and 6, set it back to your standard viewing window. Okay, well I don't need to worry about the top part then. Because when I set that equal to 0, it'll give me imaginary numbers if I were to use quadratic formula. So there's nothing off of that. But let's set the bottom part. X squared minus 9, all of it squared equal to 0. Remember, whenever you have parentheses to a power equal to 0, you can drop your power. So we've got x squared minus 9 equal to 0. Take the negative 9 over, becomes a positive 9. Square root property, drop our squared, put a plus or minus square root on the other side. So we get x is equal to plus or minus 3. Okay. So we're going to have negative 3. And we'll have positive 3. And clear over here is positive infinity. And clear over here is negative infinity. We want to choose test cases, something between negative infinity and negative 3, like negative 4. Something between negative 3 and 3, like 0. And something greater than 3, like 4. Now, my derivative is right here. The bottom part's squared, so it's always positive, so I don't need to worry about it. I only need to plug it into the top part. And actually, I already have that on y1. So let's just go to our table, do second graph. I'll press delete a few times, clean those out. And I'll do negative 4, enter, 0, enter, and 4, enter. Negative, negative, negative. That's interesting. Decreasing, decreasing, decreasing. Which means there's no mins and maxes. So it's decreasing from negative infinity to negative 3. Decreasing from negative 3 to 3. And then it's decreasing from 3 on. That makes me wonder if I didn't do something wrong, but let's see. Let's graph it now. Okay. Our x-intercept. X-intercept is 1/7. So 1/7. I don't know about right there. Oops. Y-intercept is 1/9. Geez, that's pretty close together there, aren't they? Okay, it's skewing it a little bit, but it's right there. Why do I keep alt tabbing? Get my hand off that. Okay, vertical asymptote is negative 3 and 3. So negative 3 and 3. Horizontal asymptote is y is equal to 0. Like that. Okay, decreasing everywhere. Well, if I drew it up here, it'd be increasing, so I know this segment here has to be like that. It's decreasing. In this segment here, it has to skim this, and has to skim this, and has to be decreasing. Well, if I drew anything down here, it'd be increasing, so I have to start up here. And then, obviously, it goes through those 2 points, and then skims that. decreasing everywhere. And over here, if I put it down here, it'd be increasing, so decreasing, it has to be up here. And now it makes sense once I look at the graph why it's decreasing everywhere based upon what we see. Anyway, that'd be our answer.